Let's talk about inverses. Inverses are obtained by making x and y change places. That can be done in a table or in a graph or algebraically. Doesn't matter which way we do it, the basic principle is make x and y change places. So if we have an f of x right here, x values being 1, 2, and 4, y values being 5, 6, and -1. If we want to make the inverse, f inverse of x, all we need to do is what was y, make it x, what was x, make it the new y. So the y values were 5, 6, and -1. They become x values. And then x values of the original function are 1, 2, and 4. That becomes the new y. That's all there is to it when it comes to figuring out an inverse in a table. So make x values become y values and make y values become x values. And this works, of course, the other way around. So if we want to go from the inverse to the original, we just do that. We switch x and y, and we get back where we were. Now, if we are to determine an inverse graphically, we need to know that inverses reflect over y equals x line, this green dotted line. So if two functions are inverses of each other, when we graph them, they're going to reflect over the line y equals x, or we call it a 45-degree line. So if we are to reflect this blue graph here, we should obtain the inverse. So if we reflect this point, it's going to be same distance from the 45-degree line, but on the other side, so somewhere over here. And then if you recall that x and y change places here, what we said in the table. By the way, this graph and this table are not related. I'm just trying to explain the concept here. So if we recall what we said here, x and y will change places. So if we have a point right here with coordinates, let's say 1, 2, 3, 4, so let's say 5. So this will be what? 0 on x and 1, 2, 3, 4, 5 on y, so 0, 5. Mean -5. That means the point that we are going to reflect over here to the other side, which is going to be somewhere over here. So it goes reflects across under 90 degrees. That point is going to be -5, 0. Right? We simply just reflect it. And that will provide us with one more point here. So this is -5, 0. Now this point where the graph cuts the 45-degree line, this point is going to be shared with the original and the inverse. That's because whatever coordinates we have here, they're the same. X and y are the same because we are on the y equals x line. So when we flip those two values, they're still the same. So the point will not really move anywhere. So with these three points, we can actually connect them, and we should be able to have our inverse. So something like that, and then we got the reflection. Of course, it doesn't look perfect in what I did here, but that's how it's obtained. We reflect the points across, and I hope you can see approximately that this blue line and this red line are reflections of each other over y equals x line. Now, if we want to actually algebraically check if two functions are inverses of each other, we want to verify. What we need to do is do so-called composition of functions. So if we have an f of x given and g of x given, and we want to check if they are inverses or not, so inverses question mark, then this is what we need to do. We need to say f of g of x. So this is f composition g. We need to do this calculation and figure out if this is equal to x. If it is equal to x, then we need to keep going and do this composition, g composition f. Now, if this one is also equal to x, then we have inverses. These two, f and g, are inverses. If either one of these or both of them are not equal to x, so if this composition is equal to something different than x, or if this composition is equal to something different than x, or both of them, then these are definitely f of x and g of x, they are not inverses. Actually, if we do this composition and we see it's not equal to x, we don't have to even calculate the other one. The only time these two functions are inverses of each other is if both this statement and this statement are true. Thank you for watching.